Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. In the summer of 1856, in the small village of Smiljan within the Austrian Empire, a child was born during a fierce lightning storm. The midwife declared it an ominous sign, predicting the infant would be a child of darkness. His mother, Nikola Tesla, replied with prophetic wisdom, "No, he will be a child of light." This child was Nikola Tesla, and his mother's words would prove remarkably accurate, as he would literally illuminate the world with his revolutionary understanding of electricity. Tesla's childhood was marked by extraordinary mental capabilities that bordered on the supernatural. He possessed an eidetic memory so powerful that he could visualize entire machines in his mind, complete with precise measurements and operational mechanics. This mental workshop allowed him to design, test, and refine inventions without ever touching physical materials. He would construct complex devices in his imagination, run them for weeks, then mentally disassemble them to check for wear, a process he called his mental laboratory. The young Tesla exhibited peculiar sensitivities that would shape his scientific perspective. He could hear the ticking of a watch 3 rooms away and feel the vibration of a fly landing on a table through his entire body. These heightened senses, combined with his mathematical genius, gave him an intuitive understanding of the invisible forces that govern our universe. While other children played with toys, Tesla was contemplating the nature of energy itself. His formal education began at the Austrian Polytechnic in Graz, where he first encountered the direct current dynamos that would spark his lifelong obsession with electrical systems. Tesla observed the inefficiencies in these early machines, the sparking commutators, the energy losses, and the fundamental limitations of direct current distribution. His professors insisted these problems were unsolvable, but Tesla's mind was already racing toward revolutionary solutions. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. The young inventor's breakthrough moment came not through traditional experimentation, but through pure mental visualization. While walking in a Budapest park in 1882, reciting passages from Goethe's Faust, Tesla experienced what he later described as a revelation. In his mind's eye, he saw the solution to the alternating current motor problem that had plagued inventors for decades. He immediately drew diagrams in the sand with a stick, outlining the principles of rotating magnetic fields that would revolutionize electrical engineering. This mental breakthrough represented more than just a clever invention. It was a fundamental shift in understanding how electrical energy could be harnessed and transmitted. Tesla realized that instead of fighting the natural tendency of electrical current to reverse direction, engineers could use this alternating property to create more efficient and powerful systems. His polyphasic alternating current system would eliminate the need for commutators and brushes, reducing energy loss and mechanical wear. Tesla's vision extended far beyond simple mechanical improvements. He understood that electricity was not merely a curious laboratory phenomenon, but a fundamental force of nature that could transform human civilization. His mental experiments revealed possibilities that seemed like magic to his contemporaries: wireless power transmission, global communication systems, and electrical devices that could harness the Earth's natural electrical charge. The foundation of Tesla's genius lay in his ability to perceive electricity not as isolated phenomena, but as manifestations of universal principles. While other inventors focused on improving existing technologies incrementally, Tesla reimagined the entire framework of electrical engineering. His childhood experience with lightning had planted a seed that would grow into a comprehensive understanding of electromagnetic forces that govern everything, from molecular bonds to planetary magnetic fields. In 1884, a 28-year-old Nikola Tesla arrived in New York City with little more than the clothes on his back, a letter of recommendation, and revolutionary ideas that would reshape the world. The letter, written by Charles, Batchelor, introduced Tesla to Thomas Edison with the words, "I know 2 great men. One is you and the other is this young man." This introduction would spark one of the most significant technological rivalries in human history. Edison, already established as America's premier inventor, had built his reputation and fortune on direct current electrical systems. His Pearl street station in Manhattan represented the pinnacle of electrical technology, supplying direct current power to 85 customers within a 1-mile radius. Edison's system was practical, profitable, and proven, but Tesla immediately recognized its fundamental limitations. Direct current flows in one direction only, like water flowing down a hill. This unidirectional flow creates inherent problems for long-distance transmission. As electricity travels through copper wires, resistance causes energy to dissipate as heat, following Ohm's law precisely. To maintain usable voltage levels over distances, Edison's system required power stations every few miles, making it economically prohibitive for widespread electrification. Tesla's alternating current system operated on entirely different principles. Instead of maintaining constant directional flow, alternating current reverses direction many times per second, typically 60 cycles per second in modern American systems. This alternating property allows the use of transformers, devices that can step voltage up or down with remarkable efficiency. High-voltage transmission reduces current flow for the same power delivery, dramatically minimizing resistive losses over long distances. The mathematical relationship governing this efficiency is elegantly simple. Power equals voltage multiplied by current. By increasing voltage and proportionally decreasing current, the same power can be transmitted with far less energy loss. Tesla's system could transmit electricity hundreds of miles with minimal degradation, while Edison's direct current system became impractical beyond a few city blocks. Edison initially hired Tesla to improve his direct current generators, promising $50,000 for successful modifications. Tesla worked tirelessly, applying his mental laboratory techniques to redesign Edison's machines. Within months, he had dramatically improved their efficiency and reliability. However, when Tesla requested payment, Edison allegedly dismissed the promise as American humor, revealing a fundamental clash not just of technologies, but of ethical philosophies. This betrayal catalyzed Tesla's departure from Edison's employment and his partnership with George Westinghouse, a visionary businessman who recognized the revolutionary potential of alternating current technology. Westinghouse purchased Tesla's polyphasic system patents for $1 million plus royalties, equivalent to approximately $30 million in modern currency. This partnership would fuel the war of currents, a fierce battle for the future of electrical infrastructure. Edison launched an aggressive campaign against alternating current, emphasizing its dangers through public demonstrations. He coined the term Westinghoused as a euphemism for electrocution, and sponsored public exhibitions where animals were killed using alternating current to demonstrate its lethal potential. Edison even influenced the development of the electric chair, ensuring it used alternating current to associate Tesla's technology with death. Tesla and Westinghouse responded with scientific demonstrations showcasing alternating current's safety and efficiency. Tesla would dramatically illuminate his laboratory, allowing hundreds of thousands of volts to course through his body while remaining unharmed. These demonstrations revealed his deep understanding of electrical frequency and the human body's response to different types of electrical energy. The decisive moment came with the 1893 World's Columbian Exposition in Chicago. Westinghouse underbid Edison by half, offering to illuminate the entire fair using Tesla's alternating current system. The exposition became a showcase for electrical innovation, with Tesla's rotating magnetic field motors powering everything from industrial machinery to decorative fountains. Millions of visitors witnessed the superiority of alternating current technology firsthand. The victory was complete when Tesla and Westinghouse secured the contract to harness Niagara Falls for electrical generation. This massive project would transmit power 26 miles to Buffalo, New York, an impossible feat with Edison's direct current technology. Tesla's childhood vision of harnessing nature's electrical forces was becoming reality on an unprecedented scale. The thundering waters of Niagara Falls had captivated human imagination for millennia. But in 1896, Nikola Tesla saw something others had missed, the mechanical manifestation of the same rotating forces he had visualized in his alternating current motors. The Niagara Falls Power Project represented humanity's first large-scale attempt to harness nature's raw energy and transform it into the electrical foundation of modern civilization. Tesla's generators at Niagara operated on the principle of electromagnetic induction, discovered by Michael Faraday 60 years earlier. As the massive turbines rotated within powerful magnetic fields, they generated electrical current through the motion of conductors through magnetic flux. Tesla's innovation lay in creating polyphasic systems that could capture this mechanical energy with unprecedented efficiency. The Niagara installation consisted of 10 generators, each producing 2,500 horsepower, approximately 1.8 megawatts in modern terms. Tesla's three-phase alternating current system allowed this enormous power output to be transmitted to Buffalo, 26 miles away, with minimal energy loss. The project proved that electrical energy could be generated at remote locations and distributed across vast networks, laying the groundwork for our modern electrical grid. Tesla's understanding of natural electrical phenomena extended far beyond conventional power generation. He recognized that the Earth itself was an electrical conductor, constantly charged by lightning strikes and solar radiation. His experiments revealed that the planet maintains an electrical potential of approximately 100 volts per meter of altitude, a phenomenon now known as the atmospheric electric field. During his Colorado Springs experiments in 1899, Tesla constructed a laboratory specifically designed to study natural electrical phenomena. His wireless power transmission experiments utilized the Earth's natural electrical charge, creating artificial lightning bolts over 100 feet long. These spectacular displays were not mere showmanship. They represented systematic investigations into the fundamental nature of electrical energy propagation. Tesla's Colorado Springs notebooks reveal his discovery of terrestrial stationary waves, electrical resonances within the Earth ionosphere cavity. By generating electrical oscillations at specific frequencies, he could create standing wave patterns that circled the globe. These experiments preceded the discovery of Schumann resonances by more than 50 years, demonstrating Tesla's extraordinary ability to perceive natural phenomena through purely experimental methods. The wireless power transmission system Tesla envisioned operated on principles fundamentally different from modern radio wave propagation. Instead of broadcasting electromagnetic energy through space, his system used the Earth itself as a conductor. By establishing resonant frequencies with the planet's natural electrical characteristics, Tesla believed he could transmit power to any location on Earth without wires. Tesla's Wardenclyffe Tower project on Long Island represented the culmination of his wireless power research. The tower was designed not merely as a radio transmitter, but as a global power distribution system. The facility included a deep ground connection system that would tap into the Earth's electrical charge, while the tower itself would resonate, with the ionosphere approximately 60 miles above the surface. The theoretical foundation for Tesla's wireless power system was sound, based on his understanding of electromagnetic field theory and terrestrial electrical properties. However, the practical challenges proved insurmountable. With early 20th century technology, the enormous power requirements, the need for precise frequency control, and the inherent inefficiencies of wireless transmission made the system economically unfeasible. Tesla's experiments revealed that electrical energy behaves according to principles that transcend simple mechanical analogies. Unlike water flowing through pipes, electrical current can create resonant patterns, standing waves, and field effects that operate across vast distances instantaneously. His work with high-frequency alternating current demonstrated that electrical energy could be transmitted through gaseous media, solid conductors, and even apparently empty space. The Colorado Springs experiments also revealed Tesla's deep appreciation for the interconnectedness of natural phenomena. He observed correlations between solar activity, terrestrial magnetic fluctuations, and atmospheric electrical behavior. These observations suggested that Earth's electrical environment was influenced by cosmic forces operating on scales far beyond human experience. Tesla's vision of wireless power transmission was ultimately superseded by more practical alternating current distribution systems, but his fundamental insights into natural electrical phenomena continue to influence modern technology. His understanding of resonance, electromagnetic field propagation, and the Earth's electrical properties laid essential groundwork for radio communication, radar systems, and modern wireless technologies. The legacy of Tesla's Niagara project extends beyond its immediate technological achievements. It demonstrated humanity's ability to harness natural forces on industrial scales, transforming the raw power of falling water into the electrical energy that would illuminate cities, power factories, and enable the technological revolution of the 20th century. While the world marveled at Tesla's alternating current systems, the inventor was already exploring an invisible frontier that would prove even more transformative, the realm of wireless communication and remote control. In 1893, 3 years before Marconi's first radio patents, Tesla was demonstrating the fundamental principles of wireless technology that would eventually connect the entire planet in a web of instantaneous communication. Tesla's understanding of wireless communication emerged from his broader comprehension of electromagnetic field theory. He realized that electrical oscillations could propagate through space as electromagnetic waves, carrying information across vast distances without physical connections. This insight required a fundamental shift from thinking about electricity as flowing current to understanding it as oscillating electromagnetic fields. The mathematical foundation for Tesla's wireless work rested on James Clerk Maxwell's electromagnetic equations, published in 1865. Maxwell had predicted the existence of electromagnetic waves traveling at the speed of light, approximately 299,792,458 meters per second. Tesla transformed these theoretical predictions into practical technologies. Tesla's first public demonstration of wireless technology occurred at the 1893 World's Columbian Exposition in Chicago. He illuminated wireless lamps using electromagnetic induction, showing that electrical energy could be transmitted through space without physical connections. The audience watched in amazement as glass tubes glowed brightly when brought near Tesla's transmitting apparatus, demonstrating the invisible presence of electromagnetic fields. In 1898, Tesla presented an even more revolutionary demonstration at Madison Square Garden. He exhibited a radio-controlled boat, which he called a teleautomaton, responding to wireless commands from a handheld transmitter. The 3-foot-long vessel could move forward, backward, turn left or right, and activate its lights, all controlled remotely through radio waves. The audience initially suspected fraud, believing Tesla was somehow controlling the boat through hidden wires or telepathic powers. The concept of remote control was so foreign to 1890s, thinking that many spectators could not accept the scientific explanation. Tesla patiently explained that electromagnetic waves carried coded signals that activated specific circuits. Within the boat's receiver system, Tesla's radio-controlled boat incorporated several innovations that remain fundamental to modern wireless technology. The transmitter generated electromagnetic waves at specific frequencies, while the receiver was tuned to respond only to those particular frequencies. This selective tuning prevented interference from other electromagnetic sources and allowed multiple devices to operate simultaneously without mutual interference. The boat's control system used what Tesla called individualization, essentially an early form of digital coding. Different command sequences activated different functions, enabling complex remote control operations. This principle evolved into modern digital communication protocols that allow billions of wireless devices to operate simultaneously without interfering with each other. Tesla's wireless patents covered not just radio communication, but the broader concept of remote control technology. He envisioned wireless-controlled torpedoes for naval warfare, automated vehicles for transportation, and remotely operated industrial machinery. His patent descriptions read like blueprints for technologies that would not become commonplace until the late 20th century. The commercial development of radio technology proceeded along different paths than Tesla originally envisioned. Marconi focused on point-to-point communication systems, while Tesla conceived of broadcasting networks that could transmit information to multiple receivers simultaneously. Tesla's vision anticipated modern radio and television broadcasting by several decades. Tesla's wireless experiments revealed the fundamental importance of antenna design in electromagnetic wave propagation. He discovered that antenna length and configuration directly affected transmission efficiency and signal quality. His Colorado Springs experiments used antenna systems hundreds of feet tall, optimized for specific wavelengths and transmission patterns. The inventor's notebooks from this period reveal his growing understanding of electromagnetic wave propagation through the atmosphere. He identified the ionosphere's role in long-distance radio communication decades before its existence was scientifically confirmed. Tesla realized that certain frequencies could bounce off atmospheric layers, enabling communication across continents. Tesla's work with high-frequency alternating current led to innovations in wireless power transmission that complemented his communication systems. He demonstrated that the same electromagnetic principles governing radio waves could potentially deliver usable power over wireless links. These experiments laid groundwork for modern wireless charging technologies and satellite power transmission concepts. The social implications of Tesla's wireless innovations were as revolutionary as their technical achievements. For the first time in human history, information could travel instantaneously across unlimited distances. Tesla predicted that wireless communication would create a global information network, enabling real-time coordination of human activities on a planetary scale. Tesla's vision of wireless technology extended beyond simple communication to encompass automated systems that could operate independently of human intervention. His teleautomaton demonstration suggested futures where machines could perform complex tasks under remote supervision, revolutionizing everything from manufacturing to space exploration. Tesla's exploration of high-frequency electromagnetic phenomena led him into realms of physics that stretched beyond human sensory perception, revealing invisible energies that would revolutionize medicine, communications, and our fundamental understanding of the universe. His experiments with frequencies ranging from thousands to millions of cycles per second opened doorways to technologies that seemed like pure magic to his contemporaries. In 1891, Tesla began systematically investigating the properties of high-frequency alternating current, creating electrical oscillations far beyond anything previously achieved. His specialized transformers, now known as Tesla coils, could generate voltages exceeding 1 million volts at frequencies of 100,000 cycles per second or higher. These extreme conditions revealed entirely new categories of electromagnetic phenomena. Tesla's high-frequency experiments produced what he called brush discharges, luminous electrical emanations that appeared to flow like liquid fire from conducting surfaces. These discharges behaved unlike conventional electrical current, seeming to flow along surfaces rather than through conductors. Tesla realized he was observing skin effect phenomena, where high-frequency current concentrates at conductor surfaces, rather than flowing through the entire cross-section. The biological effects of high-frequency current fascinated Tesla. He discovered that alternating current at sufficiently high frequencies could pass through the human body without causing the muscular contractions associated with conventional electrical shock. This finding led to early applications in electrotherapy and contributed to the development of modern diathermy treatments for medical conditions. Tesla's investigations revealed that high-frequency electromagnetic energy could produce mechanical effects without physical contact. He observed that nearby objects would vibrate, metal powders would dance, and flames would bend in response to his electrical oscillations. These observations suggested that electromagnetic fields could exert forces across empty space, anticipating principles that would later enable radar and wireless power transmission. During his experiments with high-frequency discharges, Tesla made accidental discoveries that paralleled Wilhelm Röntgen's identification of X-rays. Tesla's equipment produced mysterious radiations that could pass through solid materials and create images on photographic plates. He independently discovered what he called radiant energy, recognizing its potential for medical imaging and materials analysis. Tesla's X-ray work preceded much of the formal scientific investigation into electromagnetic radiation beyond visible light. His photographs using radiant energy demonstrated remarkable clarity and detail, showing internal structures of the human body and hidden defects in materials. These images proved that the electromagnetic spectrum extended far beyond human visual perception. The inventor's systematic exploration of electromagnetic frequencies revealed the existence of what would later be recognized as the complete electromagnetic spectrum. Tesla realized that visible light represented only a tiny fraction of possible electromagnetic radiations, and that waves of different frequencies would have vastly different properties and applications. Tesla's high-frequency experiments led to discoveries about electromagnetic wave propagation that anticipated radar technology by several decades. He observed that electromagnetic pulses could reflect from distant objects and return to their source, carrying information about the reflecting surface's properties. Tesla patented these principles in 1897, describing systems for detecting objects through electromagnetic reflection. The inventor's notebooks reveal his understanding that electromagnetic waves could penetrate various materials to different degrees depending on their frequency and the material's electrical properties. This insight laid groundwork for applications ranging from ground-penetrating radar to microwave cooking, technologies that would not be developed until the mid-20th century. Tesla's experiments with very high frequencies produced phenomena that challenged conventional understanding of electricity and magnetism. He observed that electromagnetic energy could create standing wave patterns in space, producing regions of high and low energy density. These observations contributed to his theories about wireless power transmission and global communication systems. The biological effects of Tesla's high-frequency electromagnetic fields suggested applications that extended beyond simple electrical stimulation. He theorized that specific frequencies might resonate with natural biological processes, potentially offering therapeutic benefits. This work anticipated modern research into electromagnetic field effects on cellular functions and bioelectric phenomena. Tesla's high-frequency research revealed the importance of resonance in electromagnetic systems. He discovered that objects have natural electromagnetic resonant frequencies, and that applying energy at these specific frequencies could produce dramatic amplification effects. This principle became fundamental to radio tuning, laser operation, and numerous other electromagnetic technologies. The inventor's systematic investigation of electromagnetic phenomena across a broad frequency spectrum revealed unifying principles that connected apparently disparate phenomena. Tesla realized that light, radio waves, X-rays, and other electromagnetic radiations were manifestations of the same fundamental physical processes, differing only in frequency and wavelength. Tesla's vision of electromagnetic technology extended far beyond the immediate applications he could demonstrate. He predicted that high-frequency electromagnetic energy would enable global communication networks, remote sensing systems, and medical treatments that operated through precise frequency control. His high-frequency experiments established foundations for technologies that continue to evolve more than a century later. As the 19th century drew to a close, Nikola Tesla's experiments had revealed fundamental principles of electromagnetic energy that allowed him to envision technological possibilities far beyond his era's comprehension. His predictions about future developments in communication, energy, and even contact with extraterrestrial intelligence demonstrated an understanding of natural phenomena that transcended the limitations of contemporary scientific knowledge. Tesla's vision of global communication anticipated the Internet by nearly a century. In interviews and patents from the 1890s, he described a world wireless system that would enable instantaneous communication between any 2 points on Earth. His concept encompassed not just voice transmission, but the exchange of documents, images, and data through electromagnetic networks that would connect every human being in a planetary information web. The inventor predicted that wireless technology would eliminate the isolation that had defined human existence throughout history. He envisioned handheld devices that would allow individuals to communicate across continents, access vast libraries of information, and coordinate activities in real time, regardless of geographical separation. Tesla's descriptions of these future communication devices remarkably paralleled modern smartphones and internet connectivity. Tesla's understanding of energy systems led him to predict the development of wireless power distribution networks that would make electrical energy as universally available as air. He theorized that large-scale transmitting stations could broadcast power to receivers anywhere on Earth, eliminating the need for extensive wire networks and making electrical energy accessible to remote locations worldwide. His energy transmission theories extended beyond terrestrial applications to encompass interplanetary power systems. Tesla speculated that advanced civilizations might use electromagnetic transmission to share energy across solar system distances, enabling space travel and colonization on scales impossible with conventional propulsion technologies. These concepts anticipated modern discussions of space-based solar power and interplanetary infrastructure. Tesla's cosmic perspective emerged from his recognition that Earth existed within a vast electromagnetic environment influenced by solar radiation, planetary magnetic fields, and possibly intelligent signals from distant civilizations. His experiments with extremely sensitive receiving equipment convinced him that he had detected artificial electromagnetic signals originating from beyond Earth's atmosphere. In 1901, while working at his Colorado Springs laboratory, Tesla reported receiving structured electromagnetic signals that appeared to be artificially generated. The signals consisted of rhythmic pulses that repeated at regular intervals, unlike any natural electromagnetic phenomena he had previously observed. Tesla interpreted these signals as potential communications from intelligent extraterrestrial beings. Tesla's scientific approach to the possibility of extraterrestrial intelligence was remarkably sophisticated for his era. He reasoned that any technologically advanced civilization would inevitably develop electromagnetic communication systems, and that such systems would produce detectable signals across interstellar distances. His calculations suggested that powerful transmitters on nearby planets could generate signals detectable by sufficiently sensitive Earth-based receivers. The inventor's cosmic theories encompassed not just communication with extraterrestrial intelligence, but the possibility of detecting and harnessing cosmic energy sources. Tesla speculated that space contained vast amounts of free electrical energy that could be captured and utilized by appropriately designed collection systems. His concepts anticipated modern research into cosmic ray energy and solar wind utilization. Tesla's understanding of planetary electromagnetic phenomena led him to predict that Earth's magnetic field could be artificially manipulated for practical purposes. He theorized that large-scale electromagnetic installations could influence weather patterns, create artificial auroras, and potentially shield the planet from harmful cosmic radiation. These ideas preceded scientific understanding of Earth's magnetosphere by several decades. The inventor's biological theories suggested that living organisms were fundamentally electromagnetic systems that could be influenced by external electromagnetic fields. Tesla predicted that future medicine would use precisely controlled electromagnetic energy to treat diseases, stimulate healing, and enhance human physical and mental capabilities. His vision anticipated modern electromagnetic therapy and bioelectronics research. Tesla's predictions about automated systems extended far beyond simple remote control to encompass truly autonomous machines capable of independent decision-making. He envisioned mechanical beings that could perform complex tasks without human supervision, learning from experience and adapting to changing conditions. Tesla's teleautomatons represented early concepts of artificial intelligence and robotics. The inventor's transportation theories predicted the development of wireless-controlled vehicles that could navigate automatically along predetermined routes. Tesla described fleets of unmanned aircraft and automobiles coordinated through wireless communication networks, anticipating modern autonomous vehicle systems and drone technologies by more than a century. Tesla's environmental predictions recognized that industrial civilization would eventually face resource limitations that would require fundamentally new approaches to energy production and consumption. He anticipated the need for renewable energy systems, efficient power distribution networks, and technologies that could harness natural forces without depleting finite resources. Tesla's most ambitious vision encompassed the transformation of human civilization through electromagnetic technology. He predicted that wireless communication and energy transmission would unite humanity in unprecedented cooperation, enabling coordinated responses to global challenges and opening possibilities for expansion beyond Earth. Tesla's cosmic perspective suggested that electromagnetic mastery was a necessary step in the evolution of intelligent species throughout the universe. More than 8 decades after Nikola Tesla's death in 1943, his revolutionary insights into electromagnetic phenomena continue to shape every aspect of modern technological civilization. From the alternating current flowing through power grids worldwide to the wireless signals connecting billions of devices in global communication networks, Tesla's fundamental discoveries remain the invisible foundation upon which contemporary society operates. Tesla's alternating current system achieved complete victory over Edison's direct current approach, becoming the universal standard for electrical power transmission. Today's electrical grid represents a direct evolution of Tesla's original polyphasic system, scaled up to continental proportions. The North American electrical grid operates at 60 cycles per second, the frequency Tesla optimized for efficiency and safety over a century ago. Modern power generation technologies, from hydroelectric plants to nuclear reactors, utilize Tesla's rotating magnetic field generators to convert mechanical energy into electrical current. Wind turbines, solar thermal plants, and geothermal facilities all employ variations of Tesla's fundamental electromagnetic principles. Even advanced fusion power concepts rely on electromagnetic field control systems that trace their lineage to Tesla's pioneering work. The wireless communication revolution that defines 21st century life began with Tesla's radio patents and remote control demonstrations. Every smartphone, tablet, and wireless device operates on principles Tesla established in the 1890s. The global internet, satellite communication networks, and wireless power transmission systems all represent technological fulfillment of Tesla's original vision of planetary electromagnetic interconnection. Tesla's high-frequency electromagnetic experiments laid essential groundwork for technologies that seem miraculous even by contemporary standards. Magnetic resonance imaging systems use precisely controlled electromagnetic fields to create detailed images of internal body structures, extending Tesla's early bioelectromagnetic research into life-saving medical applications. Modern radar systems, from air traffic control to weather monitoring, operate on electromagnetic reflection principles Tesla patented in 1897. Global positioning satellites use electromagnetic signals to provide navigation accuracy that would have astounded Tesla, yet the fundamental physics remains unchanged from his original wireless transmission concepts. Electric vehicle technology represents another vindication of Tesla's vision. While Edison championed internal combustion engines, Tesla predicted that electric motors would eventually prove superior for transportation applications. Contemporary electric cars use alternating current motors nearly identical in principle to Tesla's 1888 polyphasic designs, optimized through computerized control systems. Tesla's cosmic perspective anticipated humanity's expansion into space exploration and colonization. Modern spacecraft rely extensively on electromagnetic systems for propulsion, communication, and power generation. Ion drives use electromagnetic fields to accelerate charged particles for efficient space propulsion, while electromagnetic tethers can harvest orbital energy for satellite power systems. The search for extraterrestrial intelligence continues along paths Tesla pioneered with his Colorado Springs experiments. Radio telescopes scan the universe for artificial electromagnetic signals using detection principles Tesla established. Over a century ago, projects like Search for Extraterrestrial Intelligence represent systematic applications of Tesla's conviction that advanced civilizations would inevitably develop detectable electromagnetic technologies. Quantum physics and electromagnetic field theory have revealed deeper layers of reality that Tesla intuited through purely experimental methods. Modern quantum electrodynamics describes electromagnetic phenomena with mathematical precision that confirms many of Tesla's experimental observations about field effects, resonance phenomena, and energy transmission through apparently empty space. Tesla's wireless power transmission concepts, dismissed as impractical for decades, are experiencing renaissance through modern materials science and control systems. Wireless charging technologies for consumer electronics represent the first commercial applications of Tesla's electromagnetic power transmission principles. Experimental systems for electric vehicle charging and satellite power beaming demonstrate the continuing relevance of Tesla's energy transmission vision. Contemporary renewable energy systems increasingly rely on electromagnetic storage and conversion technologies that extend Tesla's work. Superconducting magnetic energy storage systems use electromagnetic fields to store and release electrical energy with unprecedented efficiency. Smart grid technologies employ electromagnetic communication to optimize power distribution across continental networks. Tesla's prediction that electromagnetic technology would transform human consciousness through global communication has proven remarkably accurate. Social media networks, instant global communication, and real-time information sharing represent technological fulfillment of Tesla's vision of planetary electromagnetic interconnection, enabling unprecedented human cooperation. The environmental challenges of the 21st century require exactly the kind of electromagnetic mastery Tesla pioneered. Renewable energy systems, efficient power transmission, and wireless technologies offer pathways toward sustainable civilization that align perfectly with Tesla's vision of harnessing natural forces without depleting finite resources. Tesla's greatest legacy may be his demonstration that individual human intelligence, properly focused on fundamental natural principles, can generate insights that transform entire civilizations. His mental laboratory approach to invention, his systematic exploration of electromagnetic phenomena, and his cosmic perspective on technological development continue to inspire scientists and inventors worldwide. Contemporary challenges in energy, communication, transportation, and space exploration require the same kind of revolutionary thinking Tesla brought to 19th century electrical problems. His example suggests that breakthrough solutions emerge not from incremental improvements to existing technologies, but from fundamental reconsiderations of natural phenomena and their practical applications. Tesla's vision of electromagnetic technology serving human flourishing rather than mere commercial profit remains relevant as contemporary society grapples with the social implications of rapid technological change. His commitment to open scientific communication and his belief in technology's potential to unite humanity offer essential guidance for navigating the challenges and opportunities of our interconnected world.